Here, I am going to explain a little more detail on what an engineer should know about materials and manufacturing processes in machine design. When designing a machine, what is required of the design engineer? It is abilities to select proper materials and manufacturing processes to ensure the required function of the machine. Here, proper means the selections considering the balance among quality, cost, and delivery, which is called QCD. These factors should be considered holistically to find the best combination of material properties, processing methods, function of parts, and their geometric shapes. You should be noted that for proper selection of materials, a design engineer do not need to know about detailed theory of material science, metallurgy, but he or she must try to gain some understanding of standards and unspoken rules based on industry. These understandings may be obtained only through practical experiences. To design a machine considering a balance of QCD, you must first understand the numerical parameters related to materials and manufacturing processes. We have various requirements on the materials used in products around us. Some examples of the requirements are as follows. Stick to a magnet or not. Heat deforming or not heat deform. Heat melting or not melting. Strong or weak. Hard or soft. Easy to deform or hard to deform. These may be expressions about the properties of materials, but they contain ambiguities that are subjective and may change depending on situations. So, in the practice of machine design, these properties must be quantified and for design engineer to make objective decisions. The main properties of materials can be divided into three categories: mechanical, chemical, and physical properties. Mechanical properties are mainly understood as properties against external forces. Expressions such as strong or weak are determined in terms of rigidity and strength. The rigidity numerically defines the expressions of easy to deform or hard to deform, and easy to deflect or hard to deflect. Hard or soft is determined in terms of hardness. Fragile or not fragile is determined by numerical values such as toughness and brittleness. There is no room for a person to be subjective here when using such numerical properties. Next is physical properties. Physical properties are properties related to static features that includes weight, electricity, and heat. The following are the examples of physical properties. Density is used to indicate heavy or light. Conductivity is used to indicate electrically conductive or not. Linear coefficient of thermal expansion is used to indicate heat deforming or not. Thermal conductivity is used to indicate transfers heat or not. Heat resistance is used to indicate heat resistant or not. Magnetism is used to indicate stick to a magnet or not. And transparency is used to indicate colored or transparent. Chemical properties are properties related to rust and other chemical reactions. In machine design, you may need to care whether the material is easy to rust or not. This property is expressed in terms of corrosion resistance.